So today we're going to focus on the introduction to the meat of this particular chapter, which is working to understand the graphs of trigonometric functions. Today we'll focus on the graphing of sine and cosine functions. To do this, we're going to make heavy use of our unit circle. We're going to actually use the unit circle to help us generate the graphs. When you think about that, this is pretty sensible, since we actually started thinking about sine and cosine as functions when we extended them by using the unit circle. So let's start by taking a look at an example unit circle here. I just happen to have one sitting right here, and you can see this circle has a point A, which currently is the point 1, 0. It's on the x-axis, and at the edge of the circle here, up above here, you can see the x and the y coordinates of this particular point, and you can also see the angle in standard positions that this makes. Now, one of the changes that we have here is we're measuring our angle in radians, which is a little bit different from what we're used to doing with this particular kind of plot, but it makes sense. And you can see that as point A moves, we get various angles in radians. If I bring it all the way over here to 180 degrees, we get basically pi radians, and we can bring it back here and get 0 radians. We have negative radians, and that's the only problem here, is that we'll be measuring today the lower half plane will be negative measurements of radians. So what are we looking at when we graph these trig functions? What we're looking at is the relationship between the various coordinates, either x and y, and the angle. So if we watch here this object, this point A moving, what we're asking is, how does the value of the sine or the cosine function vary as the angle changes? Now remember that the sine and cosine functions, when we're talking about the unit circle, the sine and the cosine functions can be either the y coordinate when we're talking about sine, or the x coordinate when we're talking about cosine. So we can actually take a look at graphs of these functions by tracing out the values that points have. So let's take a moment here. We'll get ourselves set up so we're back at the unit circle standard position, 0 degree and 0 radian angle. And let's take a look at the y coordinates of this point. So now we have a point sitting here, this green point, and what this green point does is, notice it has exactly the same y coordinate, as point A. So all this is going to do is show us the y coordinate of point A. So when we're below the x-axis and we have a negative angle, you can see that the y value there is negative, so that point is below and the point is above. The horizontal motion of this particular point is controlled by the angle. So when we have an angle of 0 degrees and 0 radians, the point that we're looking at is at an x-coordinate of 0. And as we increase the angle, as we increase the radian measure of our angle, the x-coordinate of this particular point increases. Notice that this point reaches a maximum here at pi over 2 radians, or 90 degrees. This ends up with a y-coordinate of 1. You can see that y-coordinate of 1 right here. And then it begins to descend, and as we keep doing this, as we keep going around and around the circle, this graph is going to repeat itself. So let's actually let this go, and we'll take a look at what this looks like. You can see this point rises and falls, and then because we're measuring negative radians for points below the x-axis, it actually jumps over to the other side. But we can trace out the shape of the graph that this object produces as it travels along the x-axis, as the angle changes. You can see this graph right here. This is the shape of the graph that this object traverses as it goes through its motion. So what we have here is a graph that represents the y coordinate of the point, which, because we're on the unit circle, is the sine function, and the x coordinate here of our green point that's moving along this track, the x coordinate of this point represents the angle that we're looking at, the angle in degrees that we're observing. So let's go ahead and talk about this in a little bit more concrete way. And we'll start this by talking about one of the properties of these functions. Sine and cosine are what we call periodic functions. If we recall what the graph that we were looking at earlier looks like, the graph of that function does something like this. And it does this forever along the x-axis. As we move down the x-axis, this graph would just continue to do this. This graph is a repeating graph, and that's really the essence of what we mean when we talk about a periodic function. A periodic function is a graph that repeats itself on a regular basis. So we can go ahead and write that definition here. A periodic function is simply a repeating graph, and we're not very used to seeing repeating graphs in the work that we have done so far. To define it in terms of function notation, a function is periodic if the function is equal to the function at some other x value for all x. In other words, if we shift the graph over by a units, we end up with the same function value. Okay? We can see that on the sine graph. We'll look a little bit more closely at that in the minute. But then we say that this particular function has a period of a. So a represents the amount of x-axis distance we have to travel in order for the graph to begin repeating itself. So let's take a look now at this model a little bit more closely and take a look at some of the properties of our sine function. So here we'll construct a graph, and we're going to be very used to measuring and dealing with our horizontal axis in terms of angles, simply because we are going to be using radians quite a bit. So if this is our horizontal axis and this is our vertical axis, we'll maybe go between 1 and -1, we can generate a graph of the sine function by thinking about some of the values we know about. We know that when the angle is 0 radians, that sine is 0. We know that when we're at pi, or 180 degrees, the y-coordinate goes back down to 0 again. And the same at 2 pi, the same at 3 pi, and the same at 4 pi. And we know that at 90 degrees, or at pi over 2 radians, the function has a maximum. At 3 pi over 2, it's down at -1. And we can generate this graph now by simply repeating this particular process. So if I were to sketch a graph of the sine function would look something like this. So this is a periodic graph. Now this is a graph that repeats itself every so often. In fact, we can see here that at this particular point and at this particular point the graph is doing exactly the same thing. So we would call this one period. And for this particular graph, for the graph of sine of x, the period happens to be 2 pi. If you notice, it repeats itself at pi over 2 and at 5 pi over 2, and the distance between those is 2 pi. We could also look at these 2 points. Notice that these 2 points repeat themselves also, and they are a distance 2 pi apart. This point here and this point here repeat themselves, and they are 2 pi apart. Now you may stop and say, well, wait a minute, isn't there repetition between this point and this point? They both cross the x-axis at those 2 points. You have to be careful, though, because the graph is not doing exactly the same thing. Remember that we're looking for where the function repeats itself, and while the function has the same value here, at this particular point the function is increasing, at this particular point the function is decreasing. So those 2 points are not one period apart. The function is actually doing different things at those 2 places. Another thing we can talk about for our trig function here this morning is amplitude. Notice that the values of our trig functions never go above or below 1. It's bounded by 1 on either side. That makes sense because our point is actually a point on the unit circle, and the y-coordinate of our point can never extend past the unit circle. It can never go outside of being +1 or -1. So another quantity we can discuss when we talk about this basic trig function is that it has an amplitude of 1. and amplitude is simply the size of the oscillation. The fact that this repeats itself and has a period is one thing, and the fact that this goes up to a maximum of 1 and down to a minimum of 1 means that it's oscillating or going back and forth between positive 1 and negative 1. Another thing to note about our sine function, there's plenty of things to see here, lots going on, is where the function has roots, where our sine function has zeros. And our sine function has zeros at every integer pi. Notice that our function crosses the x-axis at every integer value of pi. So we have roots at every value of pi. We can express that by saying here that the roots of sine of x are at n pi. So n being an integer here. As long as n is an integer, we have a root of our sine function. So n is an integer like -3, -2, -1, 0, 1, 2, 3, all those different values. So any whole number value of pi, we have a root. That's a very useful thing. Later on we'll be solving trigonometric equations, and this will be useful for us. It's also useful because it helps us to track values of sine. Right? One of the things that we've been struggling with in class is learning to work with the unit circle and memorize trig values. The graph actually can be very helpful in helping us to understand what's going on here. Well, let's go ahead and talk now about cosine and see what the cosine graph looks like. Recall that the cosine graph, and we'll generate the cosine graph here in a slightly different way,